Hi, I'm Husky. You may know me as that Deadlock YouTuber that uploads like 3 times every year. Maybe you know me as the creator of that one social network. Hell, maybe you even know me for that Animal Jam machinima I made when I was 12. Either way, for the last 4 to 6 years, I've had a game that I've always wanted to make. Over that time, I've tried making it in various different engines, but never got very far and always ended up thinking something along the lines of, I'm not ready for a project this big, I'll come back to this later. And well, I think I've finally reached the point where I feel I'm fully ready for it. My idea is for a game called LIGHTLESS, a roguelike MMO set in a cyberpunk world where everyone is an anthropomorphic wolf and you have to try to make enough money to pay bills you need to survive. My main inspirations have been 3 other games. The first and earliest was something you probably haven't heard of, a door game for bulletin board systems called Darkness, which is a very similar premise, albeit being completely text-based and definitely more of its era. Secondly, one of my favorite games, old school RuneScape. It's something I've enjoyed putting a lot of time into, albeit not as much as some others have. But overall, I really enjoy how calming the game can be at times, and I want to try to achieve a similar feel within my own game. And finally, Project Zomboid. I admittedly haven't played this one that much, however I really enjoy a lot of the aspects of game design it has, and want to try incorporating some of it into my own project. Now, a lot of you probably either saw the title and thumbnail or just heard me mention the cursed 3 letters in indie game development and got severely worried about the scope of this project, so I should probably go over a bit of my background. I'm a co-founder of the company legally known as Real Microsoft LLC and illegally known as Vor Microcomputers. That is to say, I have no steady income source and am basically unemployed. However, I have been programming since I was around 9 years old, with game design being something that basically always followed along with that. Albeit mostly using Unity and Monogame, I eventually transitioned to using raw OpenGL with one of my first actual game engine projects. It wasn't the best, the code ended up kind of sloppy since it was combining like 3 years of learning graphics programming, all the way from my first triangle to my first BSP tree-based light map generator, but it did teach me a lot of valuable information about how game engines work. I've also done some other flex-worthy programming projects in the past, such as hobbyist kernels on RISC-V and PowerPC, a lot of over-engineered distributed computing stuff for SillyPost. I made a search engine once. Where was I going with this? Basically, what I'm trying to say is I feel relatively confident taking this project on, and that is probably going to come back to bite me very soon. So let's go over the software stack for this project. I'm using the Rust programming language for no other reason than it's just what I'm most comfortable in. OpenGL, since it's also what I'm most comfortable in. Postgres for database stuff server-side. I'm also using some Rust libraries, Tokyo for async stuff, but only on the server side for now, CORM for database interaction server side, and binRW so I don't have to write my own binary serialization stuff, and also CertAJSON for when I'm too lazy to use binRW. Other than that, it's pretty much just the image crate and the GLTF crate, since I want to try to write most of the game-related code in this project myself. Anyway, that's enough background, I think, so here's the actual devlog now. For this project, I started out with something I usually like to do, which is making a concrete plan for a very simple base that I could build the game off of. My initial thought was to make a RuneScape clone, however, I quickly realized that making a RuneScape clone was actually a lot more complex than what I wanted to do at this stage, so I tried to figure out how I could make it even simpler. Instead, I decided to just focus on one simple aspect of the game and change that RuneScape clone idea into a web fishing clone. Can you tell I'm transgender? Anyways, so for this web fishing clone base that I wanted to build the game off of, I made a list of like 9 things I needed for the absolute basics of just catching fish and putting them in your inventory. Basic movement in a test world, multiplayer, an account system for that multiplayer system, an item/inventory system, a fish item and a fishing rod item, the ability to carry the fishing rod, the ability to cast the fishing rod and reel it back in, and the ability to get a fish if you reel it back in after a certain time. Now, some of these steps are deceptively difficult, so I'll go through each one with some insight into how I achieved them for the build that I finished this video with. Now, if you were doing this in an actual game engine, this would be like a 30-minute task at most. And surprisingly for me, even without a game engine, it was. Although that's basically only because I had already spent the last half year building up a solid 3D rendering engine that I had already used in other game projects, as well as porting a ton of my old physics code to work with this new 3D rendering engine. I feel game engines are somewhat deceptive in what they need to work, because a lot of the difficulty in making one doesn't come in the rendering, but rather they come in the physics simulations and some sort of system for managing all the stuff in the game world. My physics code is basically just dumbed down Quake 2 BSP collisions, and while it could theoretically support any shape, the current system is limited to cubes, albeit those cubes can have their vertices in any position. It's also currently limited to point collisions and axis-aligned bounding box collisions, and also has some other minor limitations in this area that I won't really get into because they're boring and not that important. Now, even with all this physics code, you still need a way to actually make the world that the physics simulation runs in. Previously, I had an actual level editor program for my old game engine, but it was very clunky, and for this project I wanted something that was just a bit nicer to work in. So I spent like a week making a tool that just converts specifically formatted Blender projects, exported to GLTF, into map files that the game can understand. This was definitely a bit tricky, mainly because I had to figure out a good way to convert triangulated cubes into non-triangulated cubes while preserving things like UV maps, but in the end I was able to achieve this. A very boring test world with 2 blocks you can collide with, and pretty much nothing else. In case you're wondering, the movement code here is pretty much just Quake movement, albeit with this weird slide thing you can do that I am 100% going to remove very soon. But yeah, it's really hard for me to say how long this step actually took because a lot of the stuff for it was done over the course of months or even years, but in the end I think it was all worth it to achieve something I could have made in Godot in like 5 minutes. Multiplayer is one of those things where basically everyone overestimates its difficulty in implementing. I was timing my implementation of basic movement replication for Lightless, and just to get to the point where 2 players could connect to a server and see each other move took around 5 straight hours of work. Keep in mind, this is also something I've implemented repeatedly in a ton of different projects in the past, so those 5 hours of work were pretty much all spent on just writing code I already knew and making it work with everything else. First of all, I started by adding a very simple entity system to the game. I don't think this will ever evolve into an entity component system. It's pretty much just a way to keep track of the things that do things versus the things that don't do anything. I decided that entity IDs should be distributed by the server since that makes replication way easier, and I created a player entity. Now, the implementation of the player entity is a bit different for the server and the client. The client has to keep track of all the inputs that the player is using so that it can properly move the player around the world, and the server pretty much just carries around a puppet that keeps state and replicates it to others on the server. Eventually, I will be adding some server-side anti-cheat to this, but I figured that I'd save that for the future as it isn't something I think is truly 100% necessary for what is basically a minimum viable demo of a game idea. Speaking of security, I also implemented some basic encryption on the connection between the client and the server. It's just x25519 shared secret generation with cha-cha-20 symmetric encryption. Definitely not what you'd want to share government secrets over, mainly just there to prevent the most basic of man-in-the-middle attacks. And speaking of the connection, I made a somewhat controversial choice here and went with TCP over UDP. I may eventually either switch over to 100% UDP or do some sort of hybrid thing where it uses both, but for now I'm lazy, I know TCP best, and it works for this demo, so I'll let the technical debt accrue for now. Now, as someone who's made like a million websites all with their own account systems, I wasn't too worried about this step being complicated. I basically just set up a very basic Postgres database schema with 2 tables, a user table and a login token table. The user table stores the user data, and the login token table stores tokens that can be sent over the network to the server when the client connects so that it can identify itself and get the right user. This probably won't be a permanent system, but it's representative enough of all general login systems that I think it works well for now. The only issues I really encountered while implementing this were that, 1, I had to deal with the edge case when a user tries to log into the server twice under the same account. I ended up just having the server log out the user on old connections when the new connection appears, and 2, I had to figure out a good way for the game code to communicate with the database code. This might sound simple at first, but there's an important difference between the two. The game code, which in this project is referred to as the world machine, is all written with the assumption that it's supposed to be running on a single thread all at once, or in programming terms, it's supposed to be synchronous. Meanwhile, the database code is written to be asynchronous, which means that it's designed to be ran on an asynchronous runtime that runs multiple tasks at once in order to decrease the amount of time spent waiting on something to happen. The async runtime I'm using, Tokyo, is designed to take advantage of both cooperative and preemptive multitasking. However, because of its usage of cooperative multitasking, running the world machine code in the asynchronous context would cause occasional lagging due to the synchronous code not ever yielding to other tasks. I'm probably explaining this poorly. Basically, we have to have 2 separate threads running at the same time, one with code that handles the database and one with code that handles the game, and we have to find a way for them to communicate with each other. The way I've solved this in the Lightless server is to have a sort of message queue of commands that the world machine can send to the database, and this is actually the same system used for sending network packets to the client. Unfortunately, this goes against my favorite network application paradigm of making everything stateless, and theoretically we could have desynchronization between the server and the database if, say, 2 server programs attempted to access the database at once. However, in the future, if I decide to support multiple servers in the same database, I plan to use a sort of mutex locking system where only one server can access certain data at once. Like, if a player connects to a server, then no other servers can have that player connect until they leave the original server. This one is actually pretty simple. It's just a lot of code you have to write, and unfortunately a lot of that code is UI code, which is always a bit not fun to write. There isn't really anything special here. I just added a column to the database to store items. They're stored as JSON so that theoretically we can make custom items without recompiling the server binary, and item functionality is just derived from an item type enum. For the inventory, I basically just copied everything from RuneScape. You have 28 slots rendered in a 4x7 grid on the bottom right. You can pick up items that are spawned on the ground repeatedly by the server, and you can drop items likewise. Item spawns are placed in the map using these empties in Blender with custom properties, then converted to entities on the server side when the map loads. They then periodically check if there are any items of the same type nearby, and if not, they spawn a new one. I also added the first potential command the world machine can send to the database, which is just a command to overwrite the saved inventory with the current one of the player. Since this section is kind of boring on its own, I'll also talk a bit about the items I added and some of the stuff surrounding that. I added a fishing rod and a fish. For now, the fishing rod doesn't have an actual texture, but I'll probably fix that eventually. The fish, meanwhile, is pretty much just a copy of the salmon from Silly Post, albeit I did recreate the texture from scratch so that I could avoid having the thick 2D lines show up on the fish model. Now, one thing about items you can do in most games is hold them, and that is actually a bit trickier than you might think. The way I've done it here is just to have a separate animation on the player skeleton that's just the arms in the position for holding the item. Then I have a special edge case in the code that gets the joint matrices where it can take in an additional animation that it uses to offset the positions in the original animation. It's not perfect, and I definitely want to improve it in the future, especially as I didn't make these animations originally with the intent to use them with this kind of animation combination, but it works for now. Putting the item in the hand is also pretty simple. I kind of just multiply the model matrix with the animation matrix from the hand bone. That's it. In order to be able to cast the fishing rod, I first added a new packet that gets sent when you click the left mouse button. I then added some code that checks the held item, and if it's a fishing rod type, it spawns a new entity I've called Bobber. The Bobber internally uses a lot of the player physics code for collision testing and movement, but otherwise is basically just a thing that's there to look pretty and indicate that your line is cast. I have some ideas in the works for making a line that connects the Bobber to the fishing rod when you cast it, but I have currently yet to implement that. When the Bobber spawns, it gets an initial velocity based off of the direction the player is looking and then just kind of flops onto the ground and eventually stops moving due to friction. And after I got this code working well, I added a check in the initial fishing rod cast to see if there's already another Bobber that's been fired by the player, and if there is, then instead it removes the Bobber. The Bobber itself is also what stores state for the fishing interaction, where currently it just stores the ID of the player who casted it, as well as a countdown that adds a fish to the player's inventory and despawns itself when it reaches 0. So, as a rule of thumb, I try to always playtest my projects with a couple of friends every time I do a significant amount of work, mainly in this case to make sure that I don't have any bugs that I missed by only testing on my own computer. I was also told that this map with 2 cubes and a floor was a little boring, so I added one of my favorite places, 7-Eleven. And while adding 7-Eleven, I also found a ton of extra physics engine bugs that I had to fix, so one afternoon of debugging my BSP code later, I was ready for the playtest. I'd personally say things went well. I mean, there's literally no gameplay, so I couldn't really have any actual playtesting done with, like, feedback and stuff, but at the very least, no one had any crashes or bugs. For the next video I do, I'll probably try to have an actual game loop that people can try and leave feedback on, since that's usually where I find the most useful game development info. In the meantime, I've been working on adding cool things to the game engine, like the ability to drive cars and kill people, but I mostly just wanted to make this video so that people could actually see what I've been working on, as well as hopefully generate a bit of interest for the project, since I've heard that marketing is something that's generally useful for the success of most things. Speaking of which, I have a Discord server linked below that you can join if you're interested. I also linked a Silly Post group for LIGHTLESS that you can join if you're on Silly Post, and if you aren't on Silly Post, you can mention me on the Discord server and I'll give you an invite code. I also have donation stuff, but I feel bad mentioning that in the video, so if you want to donate to me, you'll have to go on a quest to find the links for that yourself. If people are actually interested, then maybe I'll even say what service it's on in the next video. Alright, bye.